Welcome back to The Observable Unknown. Tonight, we turn to language not as metaphor, not as symbol, but as neural force. Words do not merely describe the world, they alter how the brain predicts it, parses it, and prepares to act within it. To speak is not to label experience after the fact, it is to reshape perception in real time. The question before us is not poetic, it is biological. What does language do to the brain that hears it, thinks it, and lives by it? For much of the 20th century, language was thought to reside in two primary regions, Broca for production, Wernicke for comprehension. That model no longer holds. Work by Stanislas Dehaene at the Collège de France has demonstrated that language recruits a distributed cortical network, including temporal, frontal, and parietal regions that interact dynamically with attention, memory, and prediction. Reading, for example, activates what Dehaene calls the visual word form area, a region not evolved for language, but repurposed through learning. Language, then, does not occupy the brain, it reorganizes it. At the Massachusetts Institute of Technology, neuroscientist Evelina Fedorenko conducted a series of functional magnetic resonance imaging studies showing that the brain maintains language-specific circuits, distinct from general intelligence. Syntax can activate language regions even when meaning is absent. Meaning can activate conceptual networks even when grammar collapses. This separation tells us something crucial. Understanding is not a single process, it is an assembly of neural negotiations. Language unfolds in time, and the brain tracks it with astonishing accuracy. At New York University and later at the Max Planck Institute, David Popel demonstrated that the auditory cortex parses speech across multiple temporal windows simultaneously. Fast oscillations track phonemes, slower rhythms track syllables and phrases. Your brain listens on several clocks all at once. The observable unknown here is subtle. Comprehension is not passive reception, it is rhythmic coordination. At the Max Planck Institute in Leipzig, linguist Angela Friederici showed that grammatical structure activates frontal regions associated with anticipation. The brain does not wait for words to arrive, it predicts them. Violations of expected grammar trigger measurable neural responses within milliseconds. Language trains the brain to expect futures. To speak fluently is to forecast constantly. Research by Lisa Aziz Zadeh at the University of Southern California shows that action words activate motor regions of the brain. To hear the word grasp subtly engages the hand, to hear kick primes the leg. Meaning is embodied before it is understood. The body listens even when the voice is internal. Across these studies, a single pattern emerges. Language is not a container for thought, it is a constraint system. One that shapes attention, memory, movement, and expectation. Different languages emphasize different features of reality. Color boundaries shift. Spatial reasoning adapts. Emotional labeling alters limbic responses. The observable unknown is no longer mystical. It is mechanistic, plastic, and ongoing. Each word you use tunes your nervous system. Each phrase rehearses a future. Each inner sentence trains the brain you will inhabit tomorrow. If language can rewire perception, then attention to speech becomes an ethical act. If this interlude has stirred reflection, I would love to hear from you. You may write to theobservableunknown@gmail.com or text your reflections to 336-675-5836. And wherever you've listened to this podcast, please consider leaving a review or rating. Your words help this work reach those who need it most. Thank you for listening, for thinking carefully, and of course for choosing words that shape a conscious life. Until next time, this has been The Observable Unknown.